All right, so welcome back to the second part of this video. This is still on the last question. So just to read it one more time, a tennis ball traveling at 10 meters per second is returned by Venus Williams. It leaves her racket with a speed of 36 meters per second in the opposite direction from which it came. What is the change in momentum of the tennis ball if the 0.06 kilogram ball is in contact with the racket for 0.020 seconds? What is the average force that Venus hits from the ball, or on the ball, I should say? We were told to draw a picture with velocity vectors to show which is positive and which is negative. So that's what I did initially. I drew Venus Williams as a little stick figure. I gave her a racket, and I designated the left side as the negative side and the right side as the positive side. And that's pretty much what you want to do when you think about doing physics problems, because your right side on your coordinate grid is always that positive side, and your left side is on the negative side. So we have these initial velocities and this final velocity. So let's write this down. All right, so our final velocity was equal to 36 meters per second, and our initial velocity was equal to negative 10 meters per second. So now we can use this information in order to solve for delta V. All right, so delta V was equal to your final minus your initial. So let's plug in this information. So our final velocity, 36 meters per second, minus this negative 10 meters per second. So when I see a negative minus a negative, all I do is I create a little plus sign with that information, because a negative times a negative number is a positive number. So we have 36 plus 10 meters per second. So we have 46 meters per second there. So that is our delta V. That is the velocity that we should be using in order to solve for momentum. So the first part of this question is, what is the change in momentum of the tennis ball? And just using the information from part B, I know that the mass is equal to 0.06 kilograms. And that my change in momentum is equal to my mass times my change in velocity. So my change in momentum is equal to my mass, which was 0.06 kilograms, multiplied by that change in velocity, right? So the ball is coming towards Venus Williams, then she hits it with her racket and sends it the other way with that amount of velocity. So what is the change in velocity? Well, we have to take this number right here, 46 meters per second. And now we can just do the math and solve for that change in momentum. So that change in momentum is equal to, let me just break out my calculator, 0.06 times 46, and we should get 2.76 here, 2.76. And what are we solving for? Oh, we're solving for the change in momentum. This is going to be kilogram meters per second. All right, so I'm going to add that into my list of stuff that we know, that this momentum is 2.76 kilogram meters per second. And I'm going to jump to part B of this question. If the 0.06 kilogram ball is in contact with the racket for 0.02 seconds, what is the average force that Venus uses to hit this ball? So I already have the mass written down, so now I'm just going to write down the time that we were given in that second part of the problem. Sorry, I hit the little button there that made it go all weird. But this is 0.02 seconds. That is the time that the ball comes into contact with the racket itself. And so we can use this information in order to solve for our force. So I'll do a little different color here just so you can see that this is the first part of the problem and this is going to be the second part of the problem. That force is equal to mass times your change in velocity all over time. And again, how I got that was just using the equation that we've been using this whole time that said that our mass times our change in velocity is equal to our force times time. That is that golden equation that says that the change in momentum is equal to impulse, but it's just written out in such a way with all of the variables so that we can use it in order to solve for force. So now all we have to do is plug in our mass at 0.06 kilograms times our change in velocity. So again, that is that 46 meters per second. And we want to divide by our time. So the time that it took to hit that racket was 0.02 seconds. So the force that Venus Williams exerts on this ball, all we have to do now is multiply those two things together and divide by our time. So the force that she uses is 138 newtons. So a pretty large force there. All right, if you still have questions on this, that's okay. Just make sure that you voice them to me and continue to watch these videos. Even if the Edpuzzle is shut off, you can always go to my YouTube channel and check it out. All right, I hope this is helpful. Bye, y'all.